Hey guys, let's go over stats lesson 2.4, calculating correlation. What's our learning targets? Calculate the correlation, so we're going to be able to calculate it now. Number 2, we're going to apply the properties of correlation, learning target number 3, and learning target, sorry, that was learning target number 2, and learning target number 3, describe how outliers influence the correlation. All right, let's get into this. So, to review, if it's categorical data, then we're going to use a certain word. We're going to actually use the word correlation. Take that back. That one should have been association. We learned that in lesson 2.1. If it is numerical data, then use the word correlation. All right, so how do we calculate correlation between two variables? Well, first we need to find the mean of the first list, which is called x bar, and the standard deviation, SX. Now, I'm going to highlight this, and this is our sample standard deviation. Okay, so the first thing you have to do is find the mean of the first list and the standard deviation of the explanatory variable. Then you need to calculate the z-score. For the value of the explanatory variable for each individual. Okay, and then you're basically going to do the second thing with this next list. Find the mean of the second list. We call this the second list y bar. Y bar. And the standard deviation so previously we used SX, you can use S for standard deviation Y. Of the response variable. Calculate the z-score for each value of the response variable for each individual. For each individual, we're going to multiply the z-score for the explanatory variable and the z-score of the response variable. Number 4, we're going to add the z-score products and divide the sum by n minus 1. And I just want to highlight the reason why sample standard deviation is n minus 1. So the word sample is n minus 1. Okay, and let's get this formula now. Change colors here. Okay, the formula for correlation is, whoops, R equals 1 over n minus 1. That is the sample times the standard deviation of x times the standard deviation of y, and we're going to multiply that by the deviation, xi minus x bar over y minus the average of your y variables. Okay, so this is our formula. Okay, let's go ahead and calculate the correlation coefficient, which is the letter R, correct to 3 decimal places by hand. Okay, so what do I need in this formula? The first thing, we look back up there, we have to find the mean of the x's. So let's find the mean of our x's. I'm going to go ahead and put this into my calculator. You guys can watch me do this. Stat, edit, go top of your list, press clear, enter, go to L2, go up, clear, enter. And so I'm going to go ahead and put in all these numbers for the x. 1, enter, 2, enter, 2, enter, 3, enter. And since I'm here, I'm going to go ahead and do that for list 2. 3, 4, 5, and 6. Okay, to get the standard deviation of list 1, I'm going to go back to my home screen. So I'm going to go second mode, which is quitting. I'm going to clear all that out. I'm going to press stat. Go over here to calc, the second one, var stats. And I'm going to type in L1. So that is the number 1, but in blues. Second L1. And you should be able to press enter. Okay, this gives us a couple of information that I need. I needed x bar, the average of those numbers, which is 2, and then SX, which is standard deviation of my x list, which is to 3 decimal places, approximately 0.816. So we said this was 2, and the standard deviation is 0.816. Okay, let's go ahead and get some values now for the averages of the y list and the standard deviation of our y list. So let's do it again. Okay, I'm in the home screen. Now I'm going to press clear. I'm going to go to stat, calc, var stats, and I'm going to get list 2. So that would be second and the number 2 there. You can also get that by going to second stat. And you can just press enter. And there I have 4.5 and SX. Now don't be confused, the calculator doesn't call it the y-average. This is my list. This is the information in my second list, which we called L2. So my standard deviation, SX, is 1.291. So let's go back and write that. Okay, my average is 4.5. And my standard deviation on my second list is 1.291. Okay? All right. Remember, each of our lists has, we only have 4. So in ours, we have 4 numbers. Okay, I'm going to write the formula out again. So I have, I like them write them sideways. I don't know if that helps you guys, but let's write them sideways. 1, 2, 2, 3. And my second list was 3, 4, 5, 6. And what I need to do now is subtract them. So I have the blue minus x bar. So again, that would be 1, 2, 2, and 3. And I'm just going to subtract it by 2 here. And this gives us -1, 0, 0, and 1. And so my summation of that list would be -1 plus 1. That would be a 0. And then for the other list, I have y minus the average of the y's. So that would be 4.5. And taking this number, so 3 minus that number, okay, so this would give us -1.5, -0.5, 0.5, and 1.5. All right, so let's review what we did so far. We took all of our values and we subtracted it by their average. So we shouldn't have done summation yet, because if you look back at the formula, we get a different color that I have not used, purple. Up here, whoops, don't do that. It's supposed to be multiplication of these numbers. So I should have multiplied -1 times -1.5. Their product, I don't know if you call it product, is +1.5. Then 0 times anything is 0. 0 times anything is 0. And 1 times 1.5 is 1.5. So the summation, meaning you're adding up everything here in purple, this gives me a product of 3. So let's write down what we have in our formula. Feel free to write it all out if you want to. R equals 1 over n minus 1 times 1 over sx sy times the summation of xi minus x bar y minus y bar. Okay, so our n value is 4. The Sx comes from that number here, and the standard deviation y goes right there, so let's write that in, times 0.816 times 1.291, and then the summation of all this was that number 3. So 1 over 4 minus 1 is 1/3. And then if we multiplied you have the 3 over 1, so I just have all of this. And what you can do here is you can just multiply your 3's can cancel here. And let's go ahead and put in our calculator multiplying these two. 1 divided by 0.816 times 1.291. and you get this number, which is our correlation coefficient. Okay, so that was meant to be up here, but now it's asking us to check the answer by a calculator, okay? So I'm going to write down a bunch of directions how to do this on your calculator. And then I'll just do it on the calculator. So the first thing you need to do is we need to do steps on calculator. First we need to go into the catalog. The catalog is pressing second and then 0. And then we're going to find diagnostic on. Diagnostic on. And then we're going to press enter. And then we're going to press enter. And we'll see the word done. And these first 4 steps, you only need to do once. Okay, the other calculator steps is step number 5. You're going to press the stat button. And you're going to highlight calc and then enter. And then we're going to highlight number 5 on the list, and it'll say linear regression, and we want it in this format, AX plus B, and then you press enter. And then you're going to choose your 2 lists. Then you'll see your R value. Oops. Okay, so let's go ahead and do those same steps on this simple problem. Okay. All right, so let's go to the calculator and go through these steps. Okay, so the first thing we need to go is second 0. So the word is catalog. And second catalog. This is for the Texas Instrument calculator. And you're going to go to D, diagnostic on, and then we said we're going to enter twice. Enter says done. So that's what we wanted. Perfect. Okay. Now here, we're going to press stat, calc, and then number 5 where it says linreg. And there it kind of gives you a formula. X list name, Y list name, the frequency, you don't have to worry about that, and the second part we don't have to worry about it. The nice thing about this one, it'll even kind of tell you what to do. Okay, and it even tells you the calculated errors, dimension mismatch. That means for ours, you should have 4 numbers in list 1 and 4 numbers in list 2. So let's go ahead and click on this one. Okay, so now I'm going to just go second L1, comma, second L2. Okay, and what it did is it actually, it takes our 2 lists and it finds the correlation coefficient for what we wanted, which is your R value, which is 0.949. Okay, so I just showed you guys how to do using the calculator. So you're actually going to have to do both by hand and with the calculator. And I just wanted to highlight again, that was for the Texas Instrument TI-8384. This example I'll show you guys hopefully with my scientific calculator, but it's a Casio that can handle it. And basically, I want you to do the same thing for question number 2 here. You're going to do the same thing. The heights and arm spans of 10 senior students are shown in the table below. Calculate the correlation coefficient R correct to 3 decimal places by hand. Go ahead and press pause. I want you guys to try it out, do your best you can, and then we'll do that step by step. All right, I'm going to use my Casio scientific calculator to figure out the average and the standard deviation. So I love this calculator because it can do some really basic things that we need. So I'm going to press just mode. I want stats, so I'm going to press number 2. So to get some numbers into my list, AC, and you can just press one variable, number 1. Okay, so it gives me a list, and then I'm gonna go ahead and put in to my list the heights. 160, enter, or equals 167 equals 170 equals 161 equals 175 equals 168 173 181 176 and 184. Okay, what I'm going to do from here is I'm going to press it's stat but in yellow, so I'm going to have to press shift first. So you just press shift and you see that with that little button up there. I'm going to press stat, and then what do I want? I want go to type, so 1. Nope, that wasn't it. Try again. Shift 1. Okay, so AC. So again, shift stat. Okay, I want 4. And then here you can get very quickly X bar, the average. So I'm going to write that down. The average for the first list is 171.5. And then we're going to do it again. Stat var. Whoops. Oh, and I clicked it too fast for you guys. Var, and then I want SX because that's the sample standard deviation. Number 3 is the population standard deviation. So use the sample, number 4. Oops, I have 2 of them, so you just press delete. Delete, and then press, and now it will give me what we wanted. 7.878. Okay, go ahead and let's just do it together. Now I'm going to do the same thing for the second list, for the arm span. So I'm going to go, I just pressed mode, stat, 1 variable, and then I'm going to go ahead and type in all of these numbers now. So 162, 167, 168, 162, 178, 165, 170, 179, 176, 76183. Okay, we're going to go to Shift, Stat, Type. Nope, did it again. Try that again. You can press AC or clear, so we can press Shift 1, Data. That's already what I have. Shift 1, there it is. Var, so that's 4. And then I want the average, so you can press 2. Remember now, when you write this down, this is your average of your Y list. So 171, and then SY, that is standard deviation of the second list, but the calculator cannot differentiate that. So Shift, Stat, var, number 4, enter, 7.498. All right, let's go ahead and do that rest by hand on my tablet. All right, we just used our scientific calculator to get a bunch of information. Let's write down that information we just got. The list, the average of the list is 171.5, and the standard deviation of that was 7.878. And the second list average was 171, and the standard deviation of that list was 7.498. So that was the second list. Alright, let's go ahead and write out these lists. 160, 167, 170, 161, 175, 168, 173, 181, 176, and 184. Second list, 162, 167, 168, 162, 178, 165, 170, 179, 176, and 183. All right, what do we do next? We need to subtract our numbers from the mean. So 160, and then this number is just 1 all the way down. All right, let's get our calculator. Alright, so we're subtracting these values here. And I get negative 11.5, negative 4.5, just subtracting those values. All right, feel free to, I'm just going to go through this step by step. So now I'm going to write the y list again. Feel free to fast forward to check your answer. And we need to subtract that from the average, which was 171. Okay, so when we subtract these, I'm going to get 162 minus 171. And it should give me negative 9, negative 4, -6, negative 1, -8, 5, and 12. Okay, now I'm going to multiply these two together. I'm going to multiply these two numbers. So that would be Alright, when I multiply those two numbers together, negative times a negative gives me a positive. And if I add up that number, my summation is 513. Okay, so let's write out the formula itself for correlation and plug everything back in. 1 over n minus 1 times 1 over the standard deviation first list times standard deviation second list times the summation of x minus x bar times y minus y bar. Okay, and let's just plug in everything that we have. So the first thing I'm going to plug in is n value, and there was 10 numbers to the list. So r equals 1 over 10 minus 1, and then s of x was up here, and sy is right there. Let's write that in. 171.5. Nope. That was the average. We need 7.878, and the orange is 7.498. And then the summation of all that is just what we got, which is 513. Now, multiplying fractions, you just multiply everything in the numerator. Let me put that out in blue. And then you multiply everything in the denominator, and then you divide the blue divided by the yellow. Okay. So let's do that in our calculator. I need to take a screenshot of that so I don't freak it. Okay, so what do I got? I'm going to multiply everything in the numerator. It's 1 times 1 times 513, so that's just 513. Notice my extra set of parentheses, super important. Okay, so I'm going to open up 2 sets of parentheses. That first set of parentheses just to show the denominator bottom of the fraction, and this one's just going to be a 9 times 7.878 times 7.498. Well, our correlation is 0.965. Write that down. R equals 0.965 positive. All right, let's go ahead and show you guys how to do that by using the scientific calculator. All right, let's get that correlation coefficient using this Casio. So I'm going to press on, and I'm just going to press mode stat, which is number 2. Okay, this is the one I want. This is the one that looks linear here, number 2. A plus bx. A is the y-intercept and b is the slope. Okay, so I'm just going to punch in now. I shouldn't say punch in. I'm going to input all of the numbers on our list here. So let's go ahead and do that. Once I find it. There you are. All right, 160, 167, 170, 161, 175, 168, 173, 181, 176, 184. Okay, then you can just go up to y1. Put in your numbers. 162, 167, 168, 162, 178, 165, 170, 179, 176, 183. Okay. Now, what are we going to do? We're going to press clear, AC, and then we're going to go to stat. So shift 1. Okay. And then from here, I want reg 5. And then we just want 3, which is the correlation coefficient. Press enter, and there it is, 0.965. All right, I've moved on now to page 3. And here we're doing learning target number 2. We're going to apply the properties of correlation. So correlation goes in the first blank here, no distinction between the explanatory and the response variable. You can write in here, switch them, and it's the same. So my quick example is if you graphed, if you had some data like foot length and height, and they're both measured in centimeters, and then you switch these, so now you have height over here and foot length. Let's say my data looks like this, and then you switch the order pairs essentially in some ways, you'll figure out that the R value is the same. It's the same number. And we'll do an example that looks like that. Okay, number 2. Because the R uses the standardized values of observations, remember back to what standard values were? Well, what were they? They were z-scores. Remember, you were comparing like your science class, your history class. Well, it doesn't make sense. That's like apples to oranges. So we both convert them to, I don't know, bananas. And then actually, now you can say which one is better or not. But R does not change when we change the units of the measurements of the X and Y or both. So if you had here centimeters, but then you switch it over here to feet, it remains the same. Okay, and then the last one, the correlation R has no units of measurement because we are using a standardized values. We're using a z-score. It's just a number. So it doesn't have like units. No units. You know, like if I said, how they always tell me, hey, Mr. Ring, you're drinking too much Coca-Cola, right? And so that's a 12-ounce can, right? That wouldn't be my units, but here there are no units. All right, let's just try these examples here. Example number 3. We found the correlation of R equals negative 0.879 between hurricane speeds and knots and their central pressures in millibars. So speeds are measured in something called knots in the water. And central pressures, I guess that's kind of like, I don't know, I'm assuming like the middle of the hurricane, are measured in something called millibars. I have no idea what it is. So we have to look at these and figure out is anything wrong with these examples below. Okay, let's do these together. Suppose we wanted to consider the wind speeds in miles per hour. So instead of knots, we are changing the units. Change units. And we're changing the central pressures in inches in mercury. So instead of millibars, again, we are change units. How would the conversion affect the conditions, the value of R? So what happens to my R value? And our interpretation of the correlation coefficient. So the question is, does it change? No, doesn't change. Because which one is changing the units? That would be number 2. Where the R value does not change when we change the units. Okay. Let's try 3B. Does it matter if hurricane speeds or central pressures go on the x-axis? Does it matter what goes down here and what goes over here? The answer is what? No. Because of what reason above? Number 1, you can switch. You can switch what's here, and nothing changes. Number 3, Sam claims the correlation between hurricane speeds or central pressure is R equals negative 0.879 knots. Do you see that word knots? And what do we say up here? No, because of number 3. They don't have any units, right? Did you see it? It says R equals a number, but there's no units behind it, but we have knots there. Okay, you try number 4, and then we'll go over it. Okay, example number 4. Each of the following statements contains a blunder. Something is wrong with this. Explain in each case what is wrong. 4A. There is a high correlation between gender of American workers and their income. Okay, question. What are the answers to gender? They are male or female. And what is that? Numerical or categorical? This is categorical. Okay. Quantitative usually means what's their income? It is money. So that would be numerical or quantitative. So, question. Can we calculate the correlation? Can we calculate this information? The answer is no, because if you go back to the first one, numerical data, then we use the word correlation. I need x to be some numbers and y to be some numbers, right? So that was the issue of that problem I'm just doing right now. Okay. 4B, we found a high correlation, R, to be 1.09 between students' ratings of faculty teachings and ratings made by other faculty members. can R value be over 1? R has a maximum value of 1. Remember, R has to be smaller than or equal to 1, but bigger than or equal to -1. 4C, the correlation between planting rate and the yield of corn was found to be R equals 0.023 bushels. Question: what does this mean? That is your correlation. What is this? This is units. Can you have units? No. Correlation has no units. Okay, let's move on to the next page, page 4. Let's go ahead and learning target number 3, describe how outliers influence the correlation. We're going to do an activity here, and it's talking about outliers and correlation. So in this activity, you will investigate outliers and their influence on the correlation R. So if you guys click on this, launch the correlation and regression applet, you get this. And then if you guys can hit correlation and regression right there. And this is telling me to go smaller, so let's see if we can fit that on there. Super small. And this one needs to be bigger. Okay, so click on the graph area to add 10 points to the lower left corner so that the correlation is 0.4. Alright, so we're going to basically add our own points. I want it to be 0.4. And you can see that as I add them, I needed 0.4. Oh, try again. Okay, see what I'm doing? I'm trying to make it wider. Oof, got close. Also check the box to show the mean X and Y lines as in the screenshot. So we just click on that. Okay. It says if you were to add a point at the right edge of the graphing area, but in the same linear pattern as the rest of the points, what do you think would happen to the correlation? Add the point and see if you were correct. So what would happen if I add it? Is this R value going to change? What happened to our number? Click on the point you just added and drag it up and down along the right edge of the graphing area. What happens to our correlation? So what happens? in the center there, those lines kind of represents the averages of the x's and y's. Pretty cool, huh? Now move this point so that it is on the vertical x line. Drag it up and down along the what happens to the correlation as I move it up and down this list? The correlation pretty much stays the same, right? Remember, this is the y-axis, the y-averages. Do outliers in the vertical direction have much influence on the correlation as the outliers in the horizontal direction? Let's put this on the horizontal now. So it's changing a ton, isn't it? Briefly summarize how outliers influence the value of the correlation. So let's go ahead and write out what we just saw. What happened when we moved it up and down on the when we moved it up the correlate outliers have a greater influence on the correlation in the horizontal, right, when we moved it left and right. Outliers influence the value of the correlation more in the horizontal direction, which is your x-axis, and then the vertical direction, which is the y values. Alright, last page. Flying dinosaur or early bird. Apiotuberculops is an extinct beast having feathers like a bird, but teeth and a long bony tail like a reptile. Because the known specimens differ greatly in size, some scientists think they are different species rather than individuals from the same species. However, if the specimens belong to the same species and differ in size, because some are younger than others, there should be a positive linear relationship between the values of a pair of bones from all individuals. An outlier from this relationship would suggest a different species. Here are the lengths in centimeters of the femur, the leg bone, and the humerus, a bone in the upper arm, for 5 specimens that preserve both bones. Okay, so the femur is your pelvis to your pelvic bone to your knee bone. I don't know, just saw this on the internet. And the humerus is kind of like your shoulder to your elbow. Anyways, make a scatter plot. Okay, if you haven't already, pause this and try this on your own. So I see 40, 50, 60, 70. So this is the length of femur in centimeters. And over here, same thing probably. 40, 60, 80. And this is the length of the humerus, measured in centimeters. Okay. So that's my y, 38, 41, 38, 41. 56, 63, 56, and then 60, something like that. 59, 70. 64 and 72, so it's higher than that. And then 74, 84. Well, what do you guys think? I think there is. Yes, there appears to be a what? Strong, positive. So I'm going back to my SUDS. Strength. Anything unusual? No. Direction. We've got positive. And shape. Linear. Correlation. Correlation. So I use SUDS there? Okay. Find the correlation R by hand. Okay. I need to get this information. Let's move this down here. Oh yeah, save myself some time. Okay. So purple, I'm going to write the numbers on the list. 38, 56, 59, 64, 74. Not too many on the list, right? Alright, probably would benefit you if I just put this into this calculator here. But I don't have any of the numbers, so I need to go back to my Google document. Okay, clear out home screen. Stat, edit, go to the top of the list. Just want to check something. Now I'm lost. Okay, so I'm going to press clear, enter. Same thing up here, clear, enter. And just type down numbers. 38, 56, 59, 64, 74. And then 41, 63, 70, 72, and 84. Okay, I'm going to go to the home screen by pressing second mode to quit. I'm going to find out the standard deviation of the first one. So I'm going to press stat, calc, 1 bar stats, L1. So second one. I'm going to copy that information down. And I'll show you guys some magic. Standard deviation is SX 13.198. Okay? Now I'm going to press stat, calc, 1 bar stats, L2, second 2. And this is now, remember, this is the average of the second list, which is the average of the Y's. So 66 and SX is 15.89. Okay. I got those numbers. Okay, so what do I do here? I need to take, let's write this information in. XR is 58.2 and 13.198. And then 66 and 15.89. Okay, so I need to take the first list and subtract it from the average, which was 58.2. And then purple numbers, 30, purple, guys, purple. 38, 56, 59, 64, 74. Okay, here's magic. Ready? I'm going to go up to this list here. Stat, edit. Okay, so I'm going to list 3. And I'm going to type in L1. So again, it's L3 is highlighted, so I'm going to do L1 minus, so taking up basically all those numbers and subtracting it by 58.2. Enter. Boom! What did that just do? That just subtracted all of my numbers that I needed. And you can do that for this one. So again, L4 just kind of represents L2, so basically everything in the Y's subtracted by Y bar. And my Y bar is 66. Boom! Okay, what does that mean? Just did a bunch of math for me. That's what it did. Alright, so pictures. So this is a negative 20.2, negative 2.2, 0.8, 5.8, and 15.8. And then we just did the y's, which was 41, 63, 70, 72, and 84. And I'm going to subtract that by y bar, which was 15.89. Okay, so that should give us, let's think, 41 minus 15.89, double check. Uh-oh. Let's go back. So I'm taking L2 minus, let's try that again. I think I'm wrong. L2 minus 15.89. Okay, that's better. Those numbers were previously off. Okay, I can take a picture of this. Okay, now go back to my numbers. And just copy all those numbers we did. So just kind of as mass production subtraction for you. And it gets better. I can actually do the multiplication for us too. Okay. Now, what I wanted to do is I wanted to multiply our two lists, x minus x bar times y minus y bar. Okay, so basically, I wanted to multiply this list in orange times the one in blue. So in my calculator, I have designated, let's find out what they are. Negative 20.2 and 25.11. So we have those in L3 and L4. So, okay, those two numbers from L3 and L4. So I'm going to go at L5, and I'm going to say list 3, so second, times second 4 to get L4. Because I know we can do it all by hand, but you can think about all these calculator commands. Okay, so what did it just give me? It just multiplied for me this number and this number to give us negative 5. I'm just copying all those numbers from. It gets better, it gets better. Okay, so all of that was calculated. L3, this was L4, and this is now L5, my list 5. So if I do a 1 var stats of list 5, it will give me the summation. Let me show you. Okay, so second, quit, clear, stat, calc, 1 var stats, and then 1 L5, so second 5. And what I want there is sigma x, 834. So it added all those numbers for me, 834. Oops, that's too big. 834 is that one, okay? So, if I do this all by hand, space. Let's write the formula. Always write down the formula. My goodness, guys, always write down the formula. R equals 1 over n minus 1 times the sx times the sy times the summation of the x minus x bar times y minus y bar, okay? And there are 5 numbers in our list. And then Sx is way over here, 13.198 and 15.89. Those in this little 13.198 so small, 13.98 times 15.89. Okay, and then this number, 834. You remember, kind of multiplying all rows, right? So 834, take a picture of that, let's plug in our calculator together. So I have parentheses, 834 is the numerator, divided by, that's the denominator. So 2 sets of parentheses, 5 minus 1 is 4, times 13.198, parentheses, open parentheses, 15.89. 2 sets of parentheses, enter. 99.4%. That's pretty good. 0.994. Okay. So we found, okay, let's do it by calculator. So we already have diagnostic on, right? So I already have them in my list. Let's double check them in my list. I want those in list 1 and 2. So second mode, stat, calc, then reg, number 5. And then I just type in L1, second 1, comma, L2, so second 2. And 0.994. Explain how your value for R matches your graph in part A. R equals 0.994 has a strong, this is our SUD, strong, positive, linear correlation. Okay, construct a new scatter plot reversing the explanatory and response variables. Okay, so we switch these. Now I'm going to have the femur over here and the humerus is my writing humerus because it's over. Okay, sorry. And then you just use the order pair. So humerus 41. So we did 40, 60, 80, and then over here I did, I forgot, 40, 50, 60s, 40s, 50, 60s, and 70s. And so the first order pair is 41, 38, 41, 38, 63, 56, 63, 56, 70, 59, 72, 64, 72, 64, and then 84, 74. It's pretty much the same, right? Okay, find the new value of R2 by the calculator. What did you notice? Okay, guys, this is so easy with this. I don't have to punch it much at all. Okay, look. let's cheat. Let's do second enter, which basically means entry. Okay, and then I'm just going to switch this. L2 goes first, right? Okay, let's do it. Boom. Oh my goodness, guys, look. It switched it, but the correlation is still the same. Correlation is the same, right? Even switching the x and y's, right? That was one of our properties of correlation. Okay. Suppose that a new fossil is discovered. It has a femur of 70 and a humerus of 40. Okay, let's locate this. Humerus 40 and whoa, guys. What is up with this thing? Do you think this specimen came from the same species? Okay, so it could. It is possible, right? Can't say it's impossible, but it appears to be unusual. Where did I get the word unusual from? Suds. What effect will the new fossil have on the correlation? The new fossil will lower the correlation. Because remember, what's this big idea? We've been talking about correlation for a long time. It lowers the strength, right? This is, that blue dot is further away from that regression line, the orange one. Okay, and if you typed in 4070, whoa. Humans 40, yeah. Okay, so femur 70, 40. So if we put that into our, we can just really fast. Oh no, I messed it up. What do we say? 70, 40. Femur 70, right? So we just said femur 70. Yeah. And then enter, and then I come back out. And then watch this. Second entry. Boom. Look. Second enter. It has it in there. Wow. Did you see that? It lowers it to a 51 correlation. So I mean, show you statistically how much that one other specimen changes it. So what's the strategy then of that? Is you just keep getting more and more data. We need more and more of those fossils. That's basically what it is. So let's summarize what we've done so far. We've calculated the correlation between two quantitative variables. We've done that by hand and with a calculator. We've applied the properties. It doesn't matter if you switch the x's and y's or the units, because there are no units to it. And we described how outliers influence correlation that can lower it. That was it. See you guys.
Hello, man.